We're going to go ahead and get started. It's my pleasure to introduce to you Dr. Sarah Hager. She is from the On-Site Sewage Treatment Program, research engineer and instructor from the University of Minnesota. Dr. Sarah is an engineer, researcher, and instructor in on-site wastewater treatment program in the Wastewater Resources Center, is an adjunct assistant professor in the Bioproducts and Biosystems Engineering Department. Since 1998, she's been conducting research and providing education and technical assistance to home units of government regarding on-site wastewater treatment systems. She represents at many local and national training events regarding the design, installation, management of septic systems and related research. Her passion right now is lint in systems too, just a little side note in case you have to play trivia with her later. Sarah is a board member of, and I served actually with her on the NOWA board, and I was conference chair while she was education chair, and she served that role for going on too many years to talk about. Last time I mentioned years, I got in trouble from her. But she also serves with the Minnesota On-Site Wastewater Association as well, basically our equivalent to TOWA up there in Minnesota. She's also on the NSF International Committee on the development of wastewater treatment standards. She's also served as the chair of the Minnesota State Advisory Committee and Decentralized Wastewater System. She has a BS in Biosystems and Agricultural Engineering, a master's and PhD in Water Resource Science. So without much more than that, I want to introduce to you Dr. Sarah Alexander. Dr. Sarah Alexander was one of my professors here at Baylor years ago, so I should get more sleep before I talk.
Yeah, I thought Ron was going to introduce me because he actually knew who I was and not read that awful bio, but now you know lots about me, right? So I'm really honored to be here. Of all the conferences I go to, I'll tell you, these are always the biggest crowds. And you get this many people together excited about septic systems, that's great, right? So when I say excited, whenever I'm speaking, I try to talk about something that is both interesting but also informative. And I think this topic we're going to address is both of those things. It affects almost all of our systems, certainly not if you're off-lot discharging, but anything where you're using the soil, certainly compaction is a challenge. Thank you all. Many of you have heard me speak. I think I've been at this conference 2 times before. I think a couple years ago I was here. And last year, Dave Gustafson from our program was here, and so we're all very passionate about wastewater treatment, which is kind of odd, right? The paths we all take to get to where we're at, but our program started right around when I was born, right? It's been around a long time, and that's why we now have 3 full-time staff doing education about varying topics. We do research. Ron mentioned lint. I haven't done any work yet, but we're trying to get a grant funded to evaluate how lint travels through systems, which I think really will be an issue we'll know more about in the future. And we also do homeowner education. So at the end of this talk and tomorrow, I'm going to be talking more about how do we educate homeowners better about these systems that we're designing, we're installing, we're handing it over to them, and then what happens to those systems. So what we're going to talk about first is the keys to effective treatment. And I really am focusing on soil treatment because that's really where compaction is the problem. So in order to understand why compaction is a problem, we really need to go back and just remind ourselves what the soil is doing for us. We'll then talk about methods to limit compaction during the installation process, ideas for sites that are compacted. What if the only place you have to go got compacted? Hopefully not by you, but what about the builder, right? The homeowner. Maybe it used to be a feedlot, whatever the issue might be. And finally, education for the homeowner, because you may leave their soil dispersal system there working well, and then they compact it through what they view to be regular activities. So again, first looking at that key. So we've all seen a diagram like this, and exactly what's in your trench doesn't matter because where all the magic happens of treatment and dispersal is the soil around it. So the key thing is when we say unsaturated soil is that those pores are open, that we are going to get air, right, the oxygen around us to passively diffuse into the soil. So if that soil has been smeared or compacted, Treatment is going to be challenging. Dispersal, right, of that water moving away from the system is going to be challenging. So I mentioned unsaturated soil. It also should be natural. And it's really hard to find sometimes on some sites natural soil. But the key thing I'm going to focus on is what we do that makes the soil not natural. So it is true that, you know, if it was ever farmed, was it compacted? Sure, but we also know that if you look at any given field, the row ends where they turned around are much different than the rest of the field. So identifying areas where we have the least amount of compaction, and then looking at shallow dispersal. This is another key to effective treatment, because the fact of the matter is, generally speaking, the best soil we have is near the surface for several reasons. One, it's where all the microbes are. They want food and oxygen, and generally, the closer you are to the surface, the more food and oxygen there is. It's where we have root activity, and this all, again, gets back to oxygen transfer. So again, the air that we're breathing around us, 21% oxygen. So that we are relying upon natural diffusion for that oxygen to get to our dispersal system. So if it's 2, 3, 4 feet in the ground, there's going to be less oxygen reaching that infiltrative surface. So when we look at the first issue of unsaturated soils, when we have unsaturated soils, the pores in about half of the soil, you take any given soil, about half of the actual makeup of the soil is pores. The other half is the minerals. So when we have pores that aren't saturated, then there's going to be air with oxygen present. When we have this, then when the wastewater flows through the soil, it's going to come in contact with the soil particles. And there are some of our removal mechanisms that rely upon that, particularly when you look at phosphorus removal. Phosphorus is either absorbed or precipitated onto other minerals in the soil. So it needs time and contact for that to happen. Also, many of our bacteria and viruses are actually attracted to the soil particles. You'll see in these conditions it's aerobic, which is critical for removal of bacteria and viruses. When you think about the bacteria and viruses that you may have when you're sick, right? They live in your gut, in your intestine system, which is actually an anaerobic environment. And if it goes through just a conventional system and goes into a septic tank is the same thing, right? So actually the bacteria and viruses are not killed off in the septic tank. But the difference is when they make it to an aerobic area, so that could be in an ATU, a media filter, or our soil dispersal system, those bacteria and viruses cannot live in that environment and they're killed off. So we, again, are always striving for unsaturated flow in soil treatment systems and in media filters. So then moving over to saturated, it's the exact opposite, right? Here again, our volume, our pore space is going to be filled with water. The flow of wastewater, if it is moving through that soil, is going to be relatively quickly and through the large pores, so we're not going to get good contact. It's not aerobic, and we certainly have the risk that pathogens are not going to be removed in those conditions. So the key to this, again, is to maintain our natural soil conditions. Our soil at or near the surface is generally our best soil for treatment, for removal of organic material, bacteria, and viruses. Dispersal. So there's a lot of water going through our typical septic systems. Based on the general data we have, the average person uses 50, 60 gallons of water a day. And if you take 3 people living in a house, 3, 4 people, that equates to about 75,000 gallons of water. Now think about the average area of a septic system. That's a lot of water. So we're asking the soil to do a pretty amazing job. And here, you guys might get a lot more evapotranspiration than we get in Minnesota, because today in Minnesota we have 0, right, when the ground is frozen and covered with snow. But we still are relying upon that soil to take a lot of that water, which means, again, dispersing it below the ground. So that soil near the surface has good oxygen transfer, good evapotranspiration, and again, it's where all those microbes are. So we can damage this natural soil. So we'll talk about the difference between smearing and compaction. So smearing, again, and I'm sure you've all seen these buckets, right? I'm much more likely to smear with a sand bucket, right? All those, straight edges. But can I smear with a bucket like this? Absolutely, right? The difference is how wide of a band am I smearing? So smearing is the actual spreading and smoothing of the soil particles, and it is caused by that sliding pressure. And you know, I think about, oh, okay, you can smear a clay, right? Well, you can smear anything that has enough clay in it. So that is a sandy loam or finer textured soil can be smeared if there's enough water present. So that's really the two factors that we need is we need enough silt and clay along with some moisture, and if I have those conditions, I can see smearing. This is why if you're working in wet soil conditions, it's important to check that plastic limit to make sure you're not above that. So a little bit about smearing. The nice thing about smearing is that it can be raked out. And where you often see this is when you're digging a tank hole, right? You see that side that's all shiny. No problem, right? But when you start talking about the sidewalls of a trench or a bed where you're going to rely upon the natural soil, or it may be when you're scarifying a surface, you could be smearing it, that's when we actually need to be raking that smearing out. If not, the soil infiltration rate will be reduced. So how much it will be reduced depends on how smeared up it was. So this isn't, if you have a site and you may be out troubleshooting, you maybe didn't even install it, and you were worried it was wet when it was built, it may not fail at month 1 or year 1, but it's more of a long-term problem. 5, 10 years down the road, if they cut the infiltrative capacity by half, or the oxygen transfer, because really what you're looking at is when you see that smear, those pores just got closed off. So there's no way for oxygen to get in, and there's no way for water to move through that. So moving on to compaction. Compaction is actually 3 different things. So the first thing is it's the compression and the loss of volume. So you can all think about, right, taking a clump of natural soil, squeeze it in your hand, right, it gets smaller. But it's more than that. It's more than just compacting the volume. It's also this process of compaction, which is the translocation and resorting of the sand, silt, and clay particles. So now they're not going to be in their natural soil structure. What we see then is the collapse of their aeration pores in the given soil. And the final thing is that actually the soil gets more tightly bonded together when it's compacted. And you can think about this, right? If you're building a driveway, this is exactly what you want, right? You want that to be compacted because then you know you won't have any settling. So when you do this again, the water is actually squeezed from the soil, and this process leads to increased internal bonding. So now the soil is going to be super stuck together, which is going to be then really hard for water to move through that soil. So our goal with all of this is maintaining that pore space. So I mentioned this before, right? About half of a given soil is going to be sand, silt, and clay, and the other half is going to be the pore space. So when we compact it, you can see there's still some moisture, right? But what happens when I compact it? I see now a lot less white space. The white space is the location for air and for oxygen to be getting into our system and diffusing down. So I wanted to talk about shallow too, as far as one of the last issue as far as good treatment. So when we have shallow dispersal, and so this would be with our drain fields, it'd also be with drip, right? When you're using drip irrigation, you're putting it into the upper soil. You'll see that if there, and again, last year I spoke in New Hampshire, and they told me on their sites they take off all the topsoil. And I said if we did that with some of our sites, we wouldn't be left with anything good, right? That's the only real good dry soil we have on some of our sites. So if you're taking it off a site, you're certainly risking damaging that through those practices. There's also more and more research showing that this topsoil can assist with nitrogen removal and also removal of new contaminants of emerging concern. So when we look at things like ibuprofen, pharmaceuticals, things along those lines, we're actually finding that the soil microbes are assisting us in removing many of those contaminants. So here's one of the key reasons why shallow is beneficial. So this is, again, not any given soil, but generally across soils. You'll see the upper 16 inches here, you have almost 99% of the natural microbes that would live in that soil. So what happens if you put the bottom of your system in at 20 inches? Are some of those microbes going to go down there? Sure thing, right? You put food down there and nutrients, but when you think about it, the reason why they're naturally up there is because usually that's where you're going to have some topsoil that's black. That black is food, and there's also more oxygen present. So if we're putting it there, bacteria and fungi, which are also part of our treatment process, are going to be more naturally present. So related to this is where we're going to see our root activity. And again, this is general, not any specific site, but you'll see once you're at 24 inches here, you'll see 2/3 of the root activity is generally in the upper couple feet. So using those upper 24 inches is where we're going to see the best treatment in most of our soils. And that assumes it hasn't been compacted or smeared, which is sometimes the risk with shallower in our soils. So this then looks at oxygen levels. So this is a case study that was done on one site where they looked at what were the oxygen levels in the soil. So you can see across here is inches, right? It goes from 4 inches below the ground to 48 inches. So again, a couple inches to 4 feet in the ground. And they measured it during wet times of the year and dry times. So when you look at the wet times, the soil wasn't saturated, but it was times when we were getting some rain, right? So what you'll notice is during the wet, so remember up here at the surface, right, there's 21%. So now it has to naturally diffuse. So you can see during the dry time periods at 4 inches, we're almost at 21. We get all the way to 4 feet in the ground, and now we're down to 16 milligrams per liter. But if you look at it, if that soil is wetter, we have half as much available. So during our wetter times of the year, there is less oxygen available, but the good thing is, right, it does dry out. That we don't, at least most of us, unless you're from maybe Seattle where it rains all the time, right, our soils are actually go through wetter periods, drier periods, but even when it's wet, the soil still has oxygen in it if we're designing based on redox features and models in the soil. So I mentioned the nitrogen removal, and again, if you're not into chemistry, you can take a little nap here, right? The good thing is you all just had sugar, so I'm better than right after lunch, right? What happens is when we see a typical form of nitrogen is ammonia, so that's commonly what's leaving a septic tank. If you expose that to oxygen, that ammonia very quickly converts into nitrate. So nitrate is a problem, right? There's a federal drinking water standard for nitrate of 10 milligrams per liter. So we want to make sure before anyone would use that water for drinking in particular that we have reduced that. Well, most of the time how we look to reduce that is through some sort of denitrification system. Well, you can actually do that if you have the right natural conditions as well. So to actually denitrify, what that means is microbes that are anaerobic come along to this nitrate and they strip the oxygen off and the nitrate goes to nitrogen gas. So in order for that to happen though, you would have to have a location in your soil where things become saturated and that you have carbon. So sometimes if you have, for instance, an aerated effluent, so that could be coming from an ATU, that could be coming after going through a mound system. If it then hits a topsoil layer that has that organic material, you can see nitrogen removal. So there are actually companies now looking at, well, can we mimic that in situ, in the soil? So there's actually systems where they're looking to add carbon, right? Add wood chips. If, again, your goal is nitrogen removal. So now the real topic at hand, the title, right, was compaction is the enemy of our soil treatment area. And it has others, but it's the one we're looking at today. So we're going to discuss what happened before you were there. And if you're a designer, Google Earth is amazing, right? You can look at what happened 20 years ago on a site to know, was it a feedlot? Did they used to park all the trucks there? Things, again, and that's not just 20 years, right? You can look at a lot of historic information. sometimes the homeowners will tell you that as well, and certainly then we want to look at those sites closer. Then we'll talk about during construction, after construction, and all the while our concern again is aeration, evapotranspiration, pores, and the last thing, which I haven't touched on yet, is growing vegetation. We've all seen sites that are compacted, they can't get anything to grow. Well, if you can't get anything to grow, you're also not getting oxygen transfer into your system. So again, some techniques. This is not a good one, right, to maintain natural conditions. So we should never be driving our equipment directly over our infiltrative surface. So that to me is the area where sewage is going to be meeting the soil. So once you open up the bottom of a system, we do not want to in any way drive on that. And the next one you'll say, and I've had people roll their eyes at me, limit your foot traffic, which sounds pretty extreme, right? So if you walk across the bottom of a trench, is it going to fail? Not very likely that it's going to fail immediately, right? But I will tell you that we often, as humans, have a higher pounds per square inch than the equipment you're operating on your sites, right? We have pretty small feet for what we weigh. And I'll show you a chart coming up that really shows that, that we have. And so limiting foot traffic and or raking out footprints that are, again, right across the bottom of your system, I actually think has some merit. So we talked about raking the sidewalls, thinking about the pounds per square inch of your site, so using low ground pressure equipment, and also where is your equipment situated. So if you have a site that has some slope, this doesn't really work on a flat site because you got to work on it from some side, right? But if you have a site that has some slope, working from the upslope side of the system is always to your advantage. Because when we start putting all that water into the soil, some of the water moves down, and if it hits any sort of restriction, some of it's going to move laterally for dispersal. And if it's got a slope, it's going to move downhill. So we know that downslope of that system, we are going to see an increase of water movement. So we also don't want to compact down gradient from our system whenever possible. So some methods to limit compaction during installation. Having it be at the right moisture conditions. So this is primarily too wet, although you can also smear a soil up when it's too dry. Reducing your tire pressure to the minimal allowable pressure. So if you do this, what happens is your tires then have a bigger footprint to spread out the weight of the equipment. Probably more likely is that you're actually using tracked equipment on sites where you're concerned about compaction. So again, what a tract is going to do is take the weight of your equipment and spread it out over a much larger footprint. So some other things to consider, and again, here's a picture where they're scarifying a site, and in this case, they're going to be building a mound because I can see the sand waiting in the wings. So the key thing is, again, is that once you open a system up, whatever it is, no matter what kind of soil dispersal, you do not want to leave it open. There's research, again, showing that if that site is allowed to have rainfall across the top of it, it will develop a crust. The crust is usually only about 1/2 of an inch thick, but that crust will limit water movement. So if you do have a site where that happens, that's a site where you would want to go back in and scarify that site. But I would also say you just don't want to scarify or open up that site until you have whatever media you're going to put on top of that to cover the system. So some other strategies, here's a picture where again, the excavator is working from the upslope side. There's actually some slope across this site. Again, using smaller equipment, avoiding oversized. And the last one I'm going to show you some really interesting research on, and that's combining field operations. And what I mean by that is you're going to have equipment on your site. You're going to have to compact soil. So if you're going to do that, let's have a pathway where we dedicate it to compaction. So a few things here, again, strategies on wet sites. There are some sites where you may need to dewater. So commonly I see this for tank holes. If you have water again leaking into your tank hole as you're digging it, that's not going to create a stable excavation. So these sites again, smearing and compaction are going to be more likely because we have moisture present in the soil. So you always want to be checking the weather before construction and not be opening a system up when you expect rain to be coming. So this shows the difference. So this is looking at research that's evaluating as you have more moisture present in the soil, how deep your compaction goes. So with this example, the weight was the same. The only thing that changed was how wet the soil was. So you can see as we get wetter and wetter, now, and again, the depth here on this was 24 inches. So again, this was 12 pounds per square inch for all tires was this what this study was done at. The next one looks at a little different. It looks at increasing the axle load. So this is again the actual weighted, the weight that was placed on the soil. So here you can see, so the double whammy would be a really big piece of equipment, right? Really heavy pounds per square inch, combined with wet. We then will get the deepest compaction. And that is the hard thing about compaction is it's not all the same. I remember once I was flying out west in a plane, so I was somewhere above 10,000 feet, and the pilot said, if you look out the right side of the plane, you'll see the Oregon Trail. You can actually see a line traveling across because of how compacted that is. That's about as bad as it gets. So then you look at, well, we've had an area that's been farmed historically. Has that been compacted? Well, then it actually depends on their farming practices, right? It depends if where they turned around or where their road was out to the field. So compaction isn't the same everywhere. So this actually was another neat demo they did, and this was done at a farm demo day where they layered a dark topsoil with kind of a white sand, and they compared two, and they just drove. They just did it side by side just to show people how weight does influence things. So this was a lighter, right, piece of equipment, and what you'll notice is that those bands aren't as close together. So here, with a much heavier, you can see there was more compaction. You can just visually see it because now my bands are closer together. So when we're going to look at building on sites, we're going to excavate only when the soil is dry enough. So here again is the same soil, one that's smeared and one that's not. So I did mention that the soil can also be too dry. I don't have this issue, but I can envision there could be parts of Texas where you can actually have really dry time periods. So during those times, they can also be smeared by a bucket. So what happens during these time periods is fine soil particles are separated and stratify into layers. This stratification then impairs the movement of water. Looking at the wet side of things, though, again, the way we check if the soil is too wet generally is with a plastic limit test. So you grab a clump of that soil. The wettest soil, you are going to expect to accept water. So that might be right at the surface. It might be 6 inches. It might be 8 inches. So we're going to grab a clump of that and try to roll it into a pencil. If I can get it to be a diameter of a pencil and a couple inches thick or a couple inches long, that's above the plastic limit. And smearing and compaction are going to be much more likely. And that's really where we need to wait for the site to dry out. Another thing to consider during construction is certainly marking off your system. So you usually know where your drain field is. You're not going to drive on it, but what about the people delivering materials? And if they're doing any sort of other construction on the site, you really want to protect that system during the construction process. This picture here actually again shows a drain field that's already in place. So this one was at a community where they wanted to make sure nobody parked on it. Here's the other side of it, right? When you have a site that's been compacted, it's very easy to see, right? So here I have nice uncompacted topsoil, and here they can't grow anything, right? And the sites are side by side. Related to this is the reserve area. So if you have new construction, or it may even be an existing replacement system, where's their next system? If they in fact do have a reserve area, it's something the homeowner should know about and should be written on your design plans, but also considered being protected. This was, again, a site where it's a community site. You can see these houses back there. They're not tiny, right? You can just envision when they have company, they have graduation, that would be an awesome spot to park all the cars. So often people, again, see open space, often where our septic system dispersal area is, as available space, when it's in fact not. So if you're working on a site and there needs to be vegetation removal, the first question is, who's going to remove it? I sometimes hear homeowners say, oh, we'll take care of that ourselves, because they're trying to save money, right? So what kind of equipment are they going to bring into the site to remove the vegetation? Or are they going to hire someone to do that who's going to come in with, a giant piece of equipment and start ripping out trees? So in general, when it comes to trees, we recommend, unless they have to be removed, that you just cut them flush and just leave them in place. The process of taking those trees out, you're going to need to rip up the soil basically to do that. So the next one is, if you have a homeowner who wants to save a tree, and don't get me wrong, I love trees. But what I will tell you is, most of the trees that live where you're building your septic system, there's two things that they want. One is they don't want their roots to be compacted. So if you're driving around the tree, in the area of the tree's not going to like that. The second thing that a typical tree wants that lives here in Texas is the normal amount of rainfall you get in Texas, right? And so I'm sure it varies quite a bit. I just looked up right around here, and you guys get around 40 inches of rain a year. So the trees that grow here are used to about 40 inches of rain. So if you put a septic system right next to their tree, and I don't, even 10, 20 feet away, there's going to be a lot more water than was ever there before. And unless it's a willow, which I don't want either for other reasons, that tree may not like all that moisture. So I've seen installers go to great lengths to save a tree. 5 years later, for those two reasons I just mentioned, the tree's dead. And it would have been way easier to install the system from the beginning. So again, I'm not saying it's not worth trying to save a tree, but that's where I recommend they bring in an arborist, because then when the tree dies, they're not mad at you, right? They're mad at someone who's a tree professional. So those are things to consider. Oh, the other thing as far as if you're building anything above the ground, so you're building an acreage system, a mound system, those sites, again, you just want to make sure that excess vegetation is removed, because you don't want a barrier to water movement. So the next discussion is about roughening. So this would be, again, you're doing this with trenches, with beds, with acreates, with mounds. Again, not really with drip, because again, that's not typically the process, but what your goal here is to open up the natural soil structure, so that when you start putting water in there, there's no barrier between your media and the soil. So again, once we open that up, we're never going to drive on our loosened system. We want to make sure that during this process we don't smear or compact. I showed that picture earlier. So here's what I mentioned before about compaction when you're building systems. So you can see a typical person, so it depends on how much you weigh, right? Somewhere around 10 pounds per square inch. So now look at a typical bulldozer. Same thing, right? So now we're going to egg tractors. Certainly can get bigger, and the tractors don't get smaller these days, right? They just get bigger. A rubber tire scraper, a sheep foot roller that's designed for compaction, or a person in high heels. So it's definitely not recommended to install systems wearing high heels, right? Definitely not. And you'd be like, why is that even on the chart? It's not for a joke. It was actually, so you know who cares about this number? People who install flooring. So, right, you're wearing a nice high heel. It has a big pounds per square inch that can damage flooring. But this really gets at the whole idea of that if you're worried about driving a bulldozer across your system, that whole activity of walking across the bottom is a comparable pounds per square inch. So here's a compaction study that was done. So this study was done to see, because the general theory is, and I've heard people say this, well, I only drove across the site once. Well, that first once, that one pass is where all, not all, most of the damage happened. So they took a site and they measured the density of the soil. And then they ran a piece of equipment over it 10 times. And between each of the passes, they measured how did the density change. So you'll see that in the first pass, so this was native soils with an intact topsoil. So with the first pass over that site, 70% of the reduction, the compaction happened in the first pass. So you'll see in the second one, it was another 10%, and in the third, 5%. So now you're at 85% in 3 of 10. But I don't even really care about the second and third. It's the fact that 70% of the compaction happened the first time. So your tank gets delivered, and let's say it's a concrete tank, so it's heavy, right? It comes in and backs up over your drain field. You did it, right? You did most of the compaction that would happen how many times he drove into that site. And you may say, well, that's just one study. Well, there's actually other studies that support it that have shown as high as 90%, and it'll be worse if you have removed the topsoil, if it's been filled. You may actually see this even more accelerated. So the point of this all is that you should control traffic on your site. So anytime you are doing new home construction, this is huge. Because the amount of people coming and going off those sites, and I've seen sites where, again, the septic area ended up being like the parking lot in the middle because there was nothing else there, right? It was open space. But also, while you're having your system, while materials are being delivered, and this is everything from all of the stuff when it comes to building a home, but even on an existing site, your activities. So having a dedicated construction path that everybody uses, because we're going to compact it. There's no way to not have anybody deliver anything, right? So let's know where we're compacting. So moving on, who's landscaping? So this is something that should be identified in the contract if you're the installer. I've seen homeowners think that when you leave, it'll look like when you came, which is not what's going to happen, right? So are they going to get it back to the way it looked, or are they expecting you to do that, which is almost impossible, right? So that's a good thing to have up front. And then the other question is if it's not going to be you, do they understand the risks that come with landscaping? So our concerns would be tillage, traffic, irrigation, edible plants, planting trees or brush right across the top, bushes right across the top of your system. So those are all concerns if you're, again, not part of the landscaping discussion. So the one I really wanted to hit is irrigation. So having irrigation systems over our septic systems is, to me, kind of like beating your head against the wall, right? It's completely unproductive because we are asking our septic systems to do a lot for us. So when a system is first built, if they need to do a little light watering to get grass growing, that's one thing. But the issue is again, in an average year, and again, it depends where in Texas you are, you're somewhere around that 40 inches of rain. And even when it rains, not all of our rainfall has to go into the soil, right? Some of it can run off. So a typical household with 3 to 4 people is going to put out 75,000 gallons of water. If you then take that 75,000 gallons and you split it over the area of your drain field, in a sandy soil, right, because we can put a lot more water into a sandy soil, that equates to 59 feet of water. If you're looking at a clay loam soil, we make those bigger, it's 22 feet of water. So the last thing we need is extra water. So that's also why when we build systems, we always crown them, right? So when it does rain, that water runs off. Because I think the soil is amazing. It cleans up dirty water and it accepts it all, but let's not ask us to do more for us. And there's a lot of homeowners I know, they want that green grass, right? They want it all to look the same, But the question is, are they willing to give up longevity for that? Are they willing to stress their septic system? And some of them, the answer is going to be yes. I understand that, but all we can do is tell them why, right? So again, just some pictures showing signs of compaction, topsoil, vegetation problems, but your vegetation can tell you a lot if you're out there later doing service providing about what happened to that site, either during installation or after. So moving on to what do you do if you have a compacted site? And it's not always this obvious, right? So here's a site, and again, you probably don't see this real often, right, because there's snow in it as well, but it's really rutted up, right? I can see that there's been equipment that's driven across the site. Sometimes it's deeper, though. So whenever possible, we want to avoid compaction. That's certainly the best, but if it's something that happened after the design process, then you want to go back to either the designer or the county to talk about what are our options for this site. The next question is, how bad is it? So there's times when you're augering and you can feel compaction. When it's really bad, you can feel it with your bucket. But ultimately, having a soil pit to look at the soil and or running some hydraulic tests. So that could be a perk test, it could be a saturated hydraulic conductivity, an amusa meter, some device that actually measures how is water moving through that soil. If you have that information, you can then compare it to how that soil should perform. Another thing that often comes up is, well, I'll just give it some time and the compaction will open up. So things that do help with compaction are freeze and thaw cycles, root activity, natural weathering. But those, first of all, happen in the beginning at the very top, are never going to deal with deep compaction. And ultimately, once you've compacted a site, it's never going to be natural again. We may be able to get some of its properties back. People have experimented with adding an organic material to help. There's different techniques, but it's very difficult. So some of the methods people have tried is, well, one, let's make it bigger. If it's a loam and it's acting like a clay, well, maybe we'll size it for a clay. But the key thing above this all is they're all experimental. So all of our loading rates are based upon natural soil. So the next one is mechanical soil fracturing. So anyone down here do terra lifting? No? Well, usually someone does. So terra lifting is the proprietary way of saying this. So, and we don't even have to talk specifically about terra lifting. We've all seen people aerate lawns, right? The equipment that they come through on a site. So terra lifting is kind of a version of that where they basically aerate the soil. It was not developed for septic systems. It was actually developed for the same purpose of aerating lawns. And someone thought, well, let's try that with septic systems. To me, the experience we have had with it is that it's kind of a short-term solution to usually a bigger problem. Because most of the time when people are looking to do that, it's because their system is failing. And so now, if you get more air to the system, is it going to solve the problem? So there is no research. But the whole idea of could you aerate the soil, there's actually a company from out in the Northeast that actually has a system where they're actually pumping air into the soil to increase the oxygen levels. Could that work? They actually have some data showing it does. But those are things you're only going to do in extreme circumstances. When you absolutely have to, because they're expensive. All of these are, right? Could you try to break up the compaction? So doing deep plowing and rimping with some sort of shake implement. You could, but you want to make sure it's not wet when you're doing that too, right? Otherwise you'll just smear it up while you're doing it. And finally, I've seen sites where the only area to go was so compacted, often filled in with junk and debris, that they just take it out and backfill with other material. Usually sandier material. Also very expensive. So overcoming compaction. I mentioned you will never get soil back to natural. That's why it's so important that we protect it. If you're going to try ripping through that, you always want to do it when the soil is dry, and you need to identify the entire zone of restriction. It may be you run into restriction at, 12, 18 inches. Well, how deep does that go? How deep do you need to actually rip through? So there's research I mentioned showing that if you add organic material when you're doing that, it can help restore some of that natural soil structure. So here shows an example, and it may be a little hard to see this from where you are, but what they have here, and this is common in some ag fields, this was the depth of a disc plow. So this went around to 10 inches. So that was fine, right? The corn could grow fine. But when it got to this zone in between that 10 to 18 inches, it was at the density here was 400 pounds. So it was compacted. And once they got below that again, it opened up. So again, this was the plow pan depth. So if you were going to try it, and if you put a septic system up here, it might go through this fine, but what would happen when it would hit that restriction, right? It would really slow down. So in this case, you can see they're running their shank implement, which is what's on the back of this tractor here, through this zone to try to break it up. The downside is it's not perfect, right? Because you're not going to actually get this all loosened up. You're going to get it loosened up kind of where the shank went through. So this shows us looking at a real site what the soil might look like. So here again, going back to that one you just saw, there's actually two compacted zones where again the water would move through here, kind of hit this, right, and just stop and or severely slow down. So you would again need to go through this whole zone to really break up that soil. And it wouldn't be perfect. So now after installation, right, what can we do? And this really gets back to a lot of education. But we recommend, again, to all of our installers that it's a really great opportunity to go back after you did the installation. So sometimes you're not even hired by the homeowner, right? You may be hired by a builder, a realtor. So if you go back either in the first few weeks or months, some of the things that can happen during the visit, the first one would be, well, did anything kind of settle out in that time period, right? Were there any mistakes made? I've seen sites where there was a pump involved and the homeowner was responsible to hire the electrician. So you come back and now there's an extension cord running, right? I don't think that meets your electrical code. It certainly doesn't meet ours. So making sure the controls and the alarms are set correctly for the use pattern. So this really goes back to systems that have time dosing. You have to guess how much water is that house going to use. You don't actually know until it gets up and operating. Look for any leaks, particularly into our tanks, right? Talk to the owner about the use of their filter or screen if they have one. Are they going to clean it? Are they going to hire you to clean it? Do they know they have one? Let's start there, right? And then understanding that it's something that needs maintenance. And the one we've talked about is then looking at the final landscaping. So do they have something growing? Did they bring in 2 feet of topsoil, right? Do they have trees planted across the top? Things along those lines. So ultimately, we all have our own example of how homeowners can be stupid. So my examples particularly are related to compaction. So when the driveway is crowded, they park their cars over the septic system. I've seen boats, you name it, right? They construct a wooden deck over their septic tank, right? So you can't even get in to do maintenance. So when homeowners do things like this, they invite soil compaction, broken and damaged drain lines, and then they wonder why they have a problem with their septic system. And it's your fault, right? Even though they did things that influenced their system. So some real do's and don'ts when it comes to landscaping. One is to minimize traffic. So again, I'm not saying again the dog can't run over the drain field or they can't walk over it, but we actually don't want regular traffic. And so regular traffic usually comes from livestock, right? That they will have paths they prefer to walk on and they will compact. There's no doubt about it. So again, we don't want to exercise pets or allow them to play. Again, your area that you are feeding your horses should not be out grazing over your drain field. Never drive a car or a vehicle. Also, don't mow when the soil is wet. And this is I've even seen literature from the landscaping industry that talks about even with, I would say, normal size lawnmowers, If the soil is wet when you're out there, you're causing more compaction. So compacted soil can lead to soil erosion and impede the flow of air around the system. So a horse, for instance, exerts 23 pounds per square inch per foot. So you can envision cattle will be similar. A typical vehicle is going to be around 30 psi. And people often say, when I say, you know, the biggest thing that should be over across your site is a riding lawnmower. And the homeowner asks me, well, how big can the mower be? Right? So, and this was again from some of the landscaping. So this is a site that was mowed with a pretty big lawnmower. And you can see the tracks, right, from the lawnmower. And actually, if you have an owner that's anal like that, that's actually better because they're varying kind of their mow path, so they're not regularly compacting over the same area. So I mentioned horses, right? So here's the site, that's the drain field, right? So when you see water ponding like that, that's obviously a problem. So I mentioned a horse having a pounds per square inch of 23, right? That's flat-footed. When a horse is running across the site, their pounds per square inch is much, much, much higher. This shows numbers above 1,000 pounds. So that's why, again, it's not just the standing there, it's all that activity across the site. So I think kind of wrapping this all up, particularly looking at homeowners, homeowners need education. They don't always want it, right? And so that could be generic information. It could also be customized information. So tomorrow morning, I'm actually going to be talking about a cool free tool we have to develop educational materials for homeowners. And I know they won't all read it. I understand that education is hard, but you all interact with more homeowners than certainly I'm ever going to. So we still have to take every opportunity to educate them. Because most of them don't actually know how stupid they are, right? No, I'm just kidding. But really, they don't know that they're harming their system. So with that, if anyone has questions, I think there's just a couple of minutes here. Ron gave me the 10-minute sign about 5 minutes ago, but any questions or comments? Yep. Yeah, so the question was that soil test I talked about is the plastic limit test. And there's a national ASTM standard on the plastic limit test. The plastic limit test was actually developed for agriculture, right? Because ag has the same issues we have, that they don't want to compact soil either. They don't want to be going through fields when it's too wet. So it was developed years ago to check, are we likely to compact a site? And so our code now references it. It says you can't build if you're above the plastic limit. Oh, so you grab a clump of the soil and you try to roll it into a pencil. So if you can roll it to the diameter of a pencil, 2 inches in length, you are above the plastic limit. So it's a field test. Yep, it has a fair amount, but I mentioned a sandy loam you can do that with if there's enough moisture present. Right, so the question is, I mentioned that you change the composition of the soil. So you can never change the percentage of sand, silt, and clay, right? I can't change that, but what I can change is how those particles are glued together, right? Which is more the soil's structure. So as I compact it, now I take those sand, silt, and clay particles and I actually bind them stronger together. And that's what compaction can do. So I don't change the texture, but I can change the structure and the consistence. Consistence is if you take a clump of soil and you try to squeeze it between your fingers, some will crumble and some will be really hard. So